Hey guys, today we're going to be solving this problem, kth largest element in a string. You are part of a university admission office and need to keep track of the kth highest test score from applicants in real time. This helps to determine the cutoff for increase in admission dynamically as new applicants submit their scores. You are tasked to implement a class which, for a given integer k, it maintains a stream of test scores and continuously returns the kth highest test score after a new score has been submitted. More specifically, we are looking for the kth highest score in the sorted list of all scores. We're going to implement the kth largest class. Kth largest function initializes the object with the integer k and stream of test scores nums. The add_int value adds a new test score val to the stream and returns the element representing the kth largest element in the pool of test scores so far. Now you could see that your kth largest object will be instantiated and called as such with k and nums. Over here, we got kth largest, add. The kth largest comes in an array, and the object will send it differently. Like it will send the k value over here. This is just a constructor. So the object will give you the k value as well as the nums array values that you want. Right? Now these add. So the entire array will come to you. You will have 3, 5, 10, 9, and 4. These are the numbers you will be adding dynamically. When you add dynamically, each time you need to return the kth largest element. So let's understand what the problem actually means. Let's have a k value. Let's have it 3. Let's have an already numbers. Now these are the scores of the students that are already available. 4, 5, 6, and 7. I'm taking random values. Now a student comes in and comes with a score of 3. Now, first, answer me. What is the third largest element in this array? What is the third largest element in this array? Now, the third largest element among this array is 4, 5, 6, and 7. So the third largest is actually 5. This is the third largest element in the array. The first largest is 7, the second largest is 6, and the third largest is 5. Now let's talk about adding a new number. In this array, I'm going to be adding a new array 3. That means the scores a new student comes in with the 3. Now, after you added 3, what would be the third largest element? Still, 5 remains to be the third largest element. Now, another student comes in, but hunts you with a score of 8. Now, 3, 4, 5, 6, 7, and 8. Who do you think is the third largest element here? The third largest element would be 6. Now let's come up with another number. A student comes with a score of 13. Now, who do you think would be the third largest here? The third largest element over here would be 7. Now let's bring up another number. Let's bring up a number 9. 3, 4, 5, 6, 7, 8, 9, and 13. Now, who do you think would be the third largest element? 8. Let's build the entire array now. At the first case, when we added 3, 5 was the largest element, third largest element. When we added 8, 6 was the third largest element. When we added 13, 7 was the third largest element. When we added 9, 8 was the third largest element. This is the output they're asking for. What would be the third largest element when we added each element to the array dynamically? Coming into here, we can build a solution. Whenever a number is added, we sort the array each time, and then we do this. We sort the array and send n minus third element every single time to get the value. Let me give you an example. When we added 3, what is the size of the array? 1, 2, 3, 4, 5. We would be using array list in this case. So 1, 2, 3, 4, 5. It was 5. 5 minus the kth largest element is 3, which is 2. We sort this array every single time. Now this array, whatever our rate, is already sorted. 3, 4, 5. Now let's 0, first, second, third, and fourth. You can notice that this is the second element. We'll also see the optimized way, but for now, let's see the solution so we can understand how we derived to the optimized solution. Coming on to the second array list. This array list, we have added the element 8. 1, 2, 3, 4, 5, 6. Now, 6 minus 3. Now the index 3 holds our third largest element, 0, 1, 2, 3. Now let's come to this one here where we added the number 13. 0, 1, 2, 3, 4, 5, 6. So there are a total of 7 elements over here. I counted from 0, that's why it was 6. 0 minus 3, which was 4. That means we hold the third largest element in the fourth index, 0, 1, 2, 3, 4. Let's talk about this one where we added the element 9. 0, 1, 2, 3, 4, 5, 6, 7. So we got 8 elements. To get the third element, we do it with minus 3 and we get 5. 0, 1, 2, 3, 4, 5, and the fifth element is the third largest element. This is one of the most easiest ways that you can solve this problem. Let's solve this problem. First, we're going to be writing the variables. So we can initialize this, the values to all variables here. So we're going to use an array list here, integer list. Next, we need an int for the k. As already mentioned, when we were creating the object, we would get 2 values on our constructor. This is our constructor. So whenever the object is initialized here, we would get 2 values and we need to store it inside our class so we can use this variables. This .k equals to k, and first initialize the list inside your constructor. So array list. Now what I'm going to do is in this list. I'm going to take all these nums value and I'm going to add it to the list. Now we need to remember that this list is an array list, but the nums is an array. Nums is an array. So we need to get each of these values from the nums and add it to our list. So this is how you could do that. So many people try to do this, list equal to nums, and that's not how it's going to work. You need to create the array list and then add all of these nums one by one. So why do we need an array list? Because we're going to be adding numbers dynamically. You can see the add function over here. This is going to come in with values and we need to start adding them. Now, the function, the main function will call this whenever a number is needed to be added. So you do not have to worry about anything else. You just need to write the logic of this function. So the object will be created in the main function and the add function will be called automatically. So you just need to have your array list ready for you to add your numbers as they come in, and you need to always return the third or whatever the kth largest element is. So you really understand what the function is asking for. You do not need to work on these inputs yourself. The main function will take care of them. You're just going to write the logic. So we're going to, whenever you initialize the object, whenever the main function initializes the object, it's going to send you two values, the k value and then array. The array is going to already consist of numbers initially. So 4, 5, 8, 2. Nothing is going to be, these numbers are not going to be in there. You're just going to get the k value and you're just going to get the array. So now what you need to do here is you need to initialize a k variable and keep it ready so we know that which largest element we need to return back whenever this add function is called. Because whenever you call the add function is the only time we start returning values. And until then we don't actually return. Then we're going to do list equal to new array list. This is where we're going to initialize our new list whenever the nums is being sent and the k value is being initialized. We need to initialize our list too and add all the numbers that are inside this array. So we get a list with the already existing numbers. So whenever we add a new number, we can find out which is the kth largest element. So let's write only the logic that we need to add the values into the list whenever we get a value and return exactly the kth largest element that is asking for. To first, of course, we need to add that value on our list. So once we add it, what do we want the list to do? We want the list to sort. To do that, we're going to do collections dot sort. And how do we want this? How do we want this? List. So how are we going to sort it? Let's just have collections dot sort and list. And then what I'm going to do here is I'm going to return the value. To return the value, I'm going to say get. I'm going to say list dot size minus k value. Now you can see that this solution absolutely works, but do we actually want it? This is the solution that we're looking for. No, this is very bad because we're sorting every single time we get a number. And this costs us O(n) log n because we're sorting. Imagine adding 10,000 numbers again and again. This is very slow. Let me show you the description. You could see at most 10 power 4 calls will be made to add. So when you're doing 10 power 4 calls, you're going to sort it 10 power 4 times again and again, making this very slow. But can we make it anywhere faster? Let's have a look at the array that we're working for. We were working for an already sorted array. But let's have a look of what we're working at. At first, when I asked you to find the third largest element, what we did is we worked with only 5, 6, and 7. Remember, this is already sorted. We worked with only 5, 6, and 7, the last three numbers. When we needed to find after we added the element 8, we also worked with only the last three numbers. Here we go, only last three numbers. And only last three numbers. What do I mean by we only worked with the last three numbers? You could have a look at here. 5, 6, and 7. But when I added 8, you got only 6 and 7. You never really worked with 3 and 4. And also, the smallest number among this was removed, as 8 was coming up to the largest. And the next off, when 13 was there, you also removed the smallest number among them, and you only worked with 7 and 8. When 9 came, you removed the smallest from here and only worked with 8 and 14 when 9 came up. Another good example. Let's have an array of non-sorting elements. Let's not sort the elements. Let's have it 3, 2, 1. Only 3 elements. And let's always focus on getting the second largest element. Let's add an element 4 to this array list. When I add 4, what do you think will be the second largest element? Do I need to sort it? Yes. But do I always need to sort the entire array list? Is that my question? Do I need to sort my entire array list? Or that, do I need to maintain every single time at least the last three numbers perfectly or last two numbers perfectly? In this case, we do only need two numbers to be perfect. How do I do that? How do I ensure that at least the only numbers that I want remains to be perfectly sorted? I mean, if you do not want to sort these numbers, if you do not want to sort the entire array list, because that's what we're looking for, we do not need to sort the entire array list. What can we do to only keep the k equal to 2 number? Now, what do I mean by k equal to 2? K equal to 2 represents the third largest number, which is right over here, 3. Now let's add another number. Let's add number 5. Now I'm not going to sort it. I'm just going to write it exactly like that. I'm not going to sort it, but let's say we need to find k equal to 2. What do we do here? What do we do here? Yes, you could remove the useless numbers. Over here, 1 and 2 are completely useless because we know that 3 and 4 are the ones that we used for the last time. So let's have 3 and 4. But when 5 comes, I do not need 3 anymore. I do not need 3 anymore because it's k equal to 2. I just need the two largest numbers so that I can work on which is the second largest. Right now, what is the second largest? The second largest is 4. Now you can understand what I'm talking about here. The smaller numbers are useless. And also, when you're finding out the the kth largest number, when things are being added up dynamically, you do not need to have the previous numbers. You do not need to have the smallest number there at all. That it isn't necessary. It isn't necessary to have the smallest number with you every single time, and you could just remove that. And you can just work on with these two numbers. And also, another good observation that I want you to understand over here is we are only working, when we're working with the two numbers, we're only taking up the smallest number. Let me give another example. So for this one, we only work with two numbers, but among those two numbers, we only pick the smallest number. Another one, 2, 3, 4, 5, and 6. And over here, we include only these two numbers, and we only pick the smallest one. Now, let's have a clear look of what I'm talking about and how you could practically do this. So let's have it unsorted. 3, 1, 2, and 4. Now, so among this, what you could do is actually take the smallest numbers. Keep the smallest numbers with you. And we need a data structure that could easily do this. We only need the smallest number among the numbers that we're working on. Let's have a look here. Let's have a look. Let's have 3, 1, 2, and we need to find the kth largest element. Let's say we insert 4 inside. Now we need to have a data structure that needs to work with only two numbers, but actually hold on to the smallest number. So we're going to work with something called as the MIN HEAP, and I'm going to show you how. So we're going to work with, let's say, 3, 1, and 2. Let's say we insert the number 4. We add all of these to our MIN HEAP. So 3, 1, and 2. Let's go and add them to that MIN HEAP. The first number is 3, it's perfectly fine. The second number is 1, perfectly fine. But when it comes to 2 and we add it to our MIN HEAP, we find that we're exceeding the number of the numbers that we actually wanted to work with. So right now we add 2, but we're actually exceeding the number that we want to work with. So we're going to remove the smallest. And we're going to continue on. So we got the last two numbers. These are the numbers that we're going to work on. Okay. And when we added 4, again, we're seeming to exceed the numbers that we want. So we're going to remove 2 as well. Now, you need to really remember how the MIN HEAP is going to work. It's going to really make you understand the progress. The MIN HEAP will only contain the smallest number at the top. And it doesn't matter on what order it stores the other two numbers, or even the 3 numbers. It doesn't matter. These orders might change. And as usual, MIN HEAP is implemented using priority queue, which means you can only access the top number. And this significantly reduces the mean for sorting. You don't really sort here. What you do is only find out the smallest number among the numbers that you have and just maintain it always at the top. That is what you're doing. So there are only 2 operations that all takes place in the MIN HEAP. The first one is maintain the smallest number at the top. Okay? So it always tries to maintain the smallest number at the top. Okay? And number 2 is the other numbers can be at any order. It can store them at any order, doesn't matter, but it is only for maintaining the smallest number at the top. Now, how this one single property is actually helpful for us to solve this problem. As we already saw in a previous example, we are only working with the smallest numbers among the largest numbers. So we're going to write the code as such that we can maintain the priority queue. We're going to be maintaining the priority queue. We are maintaining the priority queue at the size of k. Okay, we're going to be maintaining the priority queue at the size of k, and we will use min heap to maintain the smallest element at the top. So when we maintain the priority queue at the size of k, and we use to maintain the smallest element at the top, and we only return what is at the top, we actually get the k largest element. Okay, because that's what we're looking at. When the size exceeds, we remove the smallest element. That's what we already looked at. When the size exceeds, we no longer need the smallest elements that are on there. In this example over here, when we added another element, we removed the smallest one over here because we never really needed that. The k value is going to be 3. Let's construct here. The number that we're going to add here is going to be 8. Let's construct the min heap. So the first element is 10. We check the size of the min heap. It didn't exceed 3. Let's continue adding elements. 10 and then 7. Now when 7 comes in, you notice that 7 is the smallest element. So 7 comes here and 10 goes next. Next comes 20. Now when you see 20 over here, you just add it. There's nothing else you can do because you see over here, the 7 is the smallest. Now when 5 comes here, you can see that it's exceeding the value because when 5 is added, I'm adding here 5, and this going to be added here. I'm adding 5 over here, so we just add it and then check it. So 5, 7, 10, and 20. You could notice that we have exceeded the k value, so right now I'm going to remove values from here, and I will be removing the smallest value because it's no longer going to be the use. You see over here at this number, can you guess what is the third largest element? The third largest element is going to be 7, so 5 is never going to be used anymore. So I remove it, and now my heap is going to be 7, 10, and 20. Let's look at the next number, which is 15. Now when I add 15 over here, what happens here? 7, 15, 10 after that, 15, and then 20. Now, in this min heap, can you guess what is the third largest element? The third largest element is 10, so we no longer going to have to use 7 here. So 10, 15, and 20 it is. Now let's add 8 to our elements. So when we add 8 over here, yes, it does exceed the value. So we're going to remove the smallest element. We're going to return the third largest element among these values, which is going to be 10. Okay, the 10 is going to be, we're going to only return the top of the min heap. So this is how min heap is maintained in a priority queue. So the first thing that we're going to do is we're going to declare variables. Okay, so let's get started and declare the variables. So we're going to have, this time we aren't going to maintain a integer. We aren't going to maintain any kind of array list. We're just going to use the priority queue here, and then we initialize the value k, and we're going to initialize it from the constructor. So the constructor is going to add all of the values to our priority queue, and inside the constructor itself, we're going to try to maintain the values. So let me just do that. So this dot k equal to k, and we're going to initialize our priority queue, new priority queue, and the priority queue is by default holding a min heap, and the max heap you have to do a comparator, but for this problem we just need this, so let's just go with the default one. We do not need to have any kind of comparison inside or any kind of sort of that. So first we're going to add a number inside our priority queue. Now the priority queue acts similar to array list. It will never know when to stop adding an element and when to remove an element. We have to write the logic for that too. So it's very simple. You're just going to check your size of the priority queue. So this is how we check it. So dot size tells you the size of your priority queue, and when you notice that it's exceeding the k values, that it's not holding the k large elements. That means when you're working with a priority queue, you only need that number of elements in your hand. So when you're adding an element, you just need two larger elements, three larger elements. So when you see that your queue is not holding that, we already told you, go ahead and remove the smallest number. So we're going to use poll to remove it. So when you do dot poll, it removes the top of the element, the smallest element. Alright? So this is how you do it for your constructor. So the next thing is the add. So when I say, hey, come on, add it. So pq.offer, you go ahead and add the value. Now it's completely fine unless and also it's not going to exceed your priority queue size. But if you notice them exceeding, then please do this. Just go ahead and put k and then pq.poll. Okay, we're going to remove that value from there, and then we're going to return pq.peak. Okay, because that's what we want. We want to return the top value. Alright, so just like we returned the n minus k value from the array list, we need to return the peak. That means the top value, the smallest value. So the time complexity of this problem. Now what do you think the offer does here? Over here, the offer. So whenever you add a value to your priority queue, it does not take O of 1 like it used to take for a list. You just add your value and just goes and adds it at the end. Never. A heap insertion will take O of log h. O of log h is O of log h. This is nothing bad. H is the heap size, the size of your heap. Why is that? Because a heap insertion takes this, because our Um, as we keep on removing the extra element, it takes of log k. O of log k. This is taken for every single addition. Okay, it doesn't take h, but it takes k because we only work with not the entire heap. We only work with the k size of heap. We do maintain the k size. So you can see here, what is the k size? The k can be nums.length minus plus 1. That means it could go for 10 power 4, but it doesn't matter. You're just working with that. Now, why do I say it's log? Why is it log? As well as it takes for pulling, like, removing as well, it's going to take O of log k. But why is that? That means the reason it's taking O of log k is because it's maintaining the smallest element at the top. And so that is why it takes log k. So it's pretty much better. The overall complexity is O of n log k because you're running the loop n times. You're running the loop n times, you're running it for all of your elements in your nums array. So it's going to take n times, as well as for your insertions performance, each and every number that you take and add to your priority queue. So that's where we say of n log k. It's not log n. You're not sorting the entire array. You are just sorting the size of your heap. The size of your heap is going to be always k. So you're just sorting out the three numbers that you already have, or the two numbers, or whatever your k size is.